Good afternoon. Today we are going to discuss about the linear differential equations and the method of solving such type of equations. Now, linear differential equations of first order are represented in this form: y dash plus pxy equal to qx. Here p and q are continuous functions on some interval I, possibly the entire real line, and we seek a solution of this form: y is equal to y as a function of x. So method for solving this type of equations, we have to first find the integrating factor. That is, this integrating factor is given in the form of e to the power integration of p dx, and the solution, the general solution, is written as yx into the integrating factor e to the power integration of p dx equal to integration of qx into the integrating factor e to the power integration of p dx plus constant c, where c is an arbitrary constant in the general solution. Now let us do this. This is called the first order linear differential equation. This one is the first order linear differential equation, and it is also called the Leibniz equation. The German scientist Leibniz, he founded this, so it is called Leibniz equation. Now we will do some examples, solve some examples for understanding it better. Suppose the differential equation is y dash plus y tan x equal to sec x, where y dash is dy dx. So first of all, we will write this equation in the form of dy dx plus py equal to q. So here, what is p? P is tan x. By comparing with this equation, equation 1, by comparing with the equation 1, we get that p equal to tan x and q equal to sec x. So our solution will be of this form. Solution will be y into integrating factor equal to integration of q into integrating factor dx plus c. So what is the integrating factor here? The integrating factor is e to the power integration of p dx. So e to the power integration of p means here tan x, and the integration of tan x is log sec x. So we will write e to the power ln sec x. So it will come to be sec x. So our integrating factor is sec x. So therefore, from the solution 2, we will write, our solution will be y into sec x equal to integration of, what is q here? Q is sec x. So sec x into integrating factor. What is the integrating factor? Sec x again. So dx plus c. That means integration of sec square x dx plus c. So if we integrate it, we will get the solution as tan x plus c. So our solution becomes y into sec x equal to tan x plus c, or y equal to sin x plus c cos x. So this is the solution. So considering this type of equation as a linear differential equation of first order, we have found the solution. First we are finding the integrating factor, then we are finding the general solution in this form, and we have shown it with the help of an example. Let us consider another example. Example 2 will be cos square x dy dx plus y equal to tan x. So we have to first get rid of the coefficient of divide dx. It should be always 1. So therefore we have to divide the whole equation with cos square x. So doing that, we are getting divide dx plus sec square x into y equal to tan x sec square x, which is of the general form, dy dx plus py equal to q. What is p here? Where p is equal to sec square x and q is tan x sec square x. So we will write find the integrating factor here. Integrating factor is equal to e to the power integration of p dx, that is e to the power integration of sec square x dx, that is e to the power tan x. Now we will write the general solution. General solution is y into integrating factor equal to integration of q into integrating factor dx plus c. So this implies y into integrating factor is e to the power tan x equal to integration of q is sec square x and integrating factor is e to the power tan x plus c, where c is an arbitrary constant. So for solving this, we can do the integration by any method you like. So we are putting z equal to tan x, suppose. So dz is equal to sec square x dx. So therefore this integration becomes this right hand side. This right hand side becomes integration of z e to the power z dz plus c. And if we do it by parts, we are getting first function integration of first function is z, integration of second is e to the power z minus integration of differentiation of first function, that is 1, integration of second dz plus c. This equal to z e to the power z minus e to the power z plus c. This equal to z minus 1 into e to the power z plus c. And if we put back the values of x, we will get tan x minus 1 into e to the power tan x plus c. So our solution becomes y into e to the power tan x equal to this. Or if we just, this can be written, if we divide the whole equation with e to the power tan x, we will get y equal to tan x minus 1 plus c into e to the power minus tan x, where c is an arbitrary constant. Now after learning about this linear differential equation of first order, we will go for Bernoulli's equation. Bernoulli's equation. Now what is the form of the Bernoulli's equation? This is of this form: dy dx plus pxy equal to qx into y to the power n. So what is the difference between the linear differential equation of first order and this Bernoulli's equation? Difference is that the right side there was only qx, here it is qx into y to the power n. So for solving it, we will have to get rid of this y to the power n from the right side, and right side will be totally a function of x, that is qx. So how to solve it? We will divide the whole equation with y to the power n. So it becomes 1 by y to the power n dy dx plus px y by y to the power n, that is 1 by y to the power n minus 1 equal to qx. So after getting this form, we will put here, for solving it, we will put z equal to 1 by y to the power n minus 1. And we will find dz dx and convert this equation of x and y in terms of z and x. And we will get that Leibniz equation. After putting this, we will get the the Leibniz equation. That means a linear differential equation of first order. And we know how to solve that. So let us do one example of that type. Example, dy dx plus y by x equal to y square. So we can see that right hand side is containing y square, which we will get rid of y square here from the right side. So how to do that? Dividing the whole equation with y square, we get 1 by y square dy dx plus 1 by y into 1 by x equal to 1. So what we have to put then? Z equal to 1 by y to the power n minus 1. What is n here? N is 2 here. By comparing with this general form, we are getting n equal to 2. So we will put here z equal to 1 by y. And then we will find out dz dy, dz dx is minus 1 by y square dy dx, or 1 by y square dy dx is equal to minus dz dx. So this is 2 and this is 1, suppose. So putting the value in 2, putting these values in 2, we get minus dz dx plus z into 1 by x is equal to 1, or dz dx minus 1 by x into z equal to minus 1. So which is again of the form linear differential equation of first order, of the form dz dx plus pz equal to q. Here p is where p is minus 1 by x. P is a function of x and q is also a function of x, and q equal to minus 1. Now we will have to find out the integrating factor. So the integrating factor becomes e to the power integration of p dx equal to e to the power integration of minus 1 by x dx.